Practice problem 1. The major activities of a research project is shown in the table on the right. Answer the following questions. Part A. Draw the precedence AOA and AON diagrams. B. Identify the critical path on AOA network. And C. Determine the expected length of the project. Hint. Start with a single node and end with a single node. So please pause here and try to answer these questions. Part A, Part B, and Part C. Draw the precedence diagrams and then identify the critical path and then determine the length of the project. And after you are done, come back to see the solution. We need to use the information given in this table to draw the AOA and AON diagram. Let's start with the AOA diagram. This table gives the activities on the first column and the immediate predecessor activities in the second column and the expected time in days in the third column. So to draw the AOA network, we need to know the activities, their lengths, and also which one comes first and which comes next. So we need to find this priority relationship, the predecessor relationship. If you look at the second column, you can see at the very end, you can see that the end node, which is not really a node, is just a dummy node. The predecessor for that is K and M. So this means that these two activities, K and M, are the last activities in the project. But we also need to know the first activities in the project. The first activities are those that do not have any predecessor. So if you look again in the table, you can see that A doesn't have any predecessor, E doesn't have any predecessor, and G doesn't have any predecessor. So A, E, and G are the first activities in the project. So to start the AOA diagram, we need to add a start node, a dummy node. I'm gonna draw it here and I'm gonna show it by S. It stands for a start. So this is a dummy node that we need to add to indicate the beginning of the project. Then we need to add the three beginning activities, A, E, and G. So A, E, and G are the arrows going out of these dummy nodes. This is A, this is E, and this is G. Now to follow up and continue, we need to find the other relationship. We need to see what comes after any of these activities. So let's figure out. Let's start with activity A. We want to see what comes after activity A. So we need to find A as immediate predecessor for those activities that comes after A. So this means that we would look at the immediate predecessor column, the second column, and we're going to look for A. So we see that there is an A here, which corresponds to C. So this means that C comes after A. Also here we have B. B comes after A. And there is no other activity that comes after A. So C and B comes after A. So I'm going to draw a node here, and C and B are those activities that goes after A. Now we go with the next activity, activity E. So we look at the immediate predecessor column and we look for E this time. If you look closely, you can see that, okay, F comes after E and there is no other activities. So I'm going to add E here after F here after E. So F is here. Next, we're going to go after G. So let's look for the activity that comes after G. So we look at the immediate predecessor for G, and we find it here. So H comes after G. The predecessor for H is G, and there is no other G here. So we're going to draw a node here and H here. Now we're going to move to the next activities. What activity comes after C, B, F, and H? Let's go with C. So we look for C here. We find out that, okay, D comes after C. So I'm going to draw a node here, and I'm going to draw D here. And we look for B now. So also there is B here, and I comes after B. But also, if you notice, D also is the predecessor for I. So it means that I is both after B and D. B and D both are the predecessor for I. So I have to make a correction here. I'm going to replot these. I'm going to create a node here, and I'm going to plot I here, and D is going to be the predecessor for I, and so is B. So now I is the activity after both B and D in our network. So now let's look for F. What comes after F? What activity's predecessor is F? So if you look here, you're gonna see that, okay, F comes before M. So M comes after F. Also I. So I and F both are the predecessor for M. So I'm going to create a node here, and I'm gonna draw M here, and F and I both has to go to this activity, this node here. So I'm going to redraw these as well. This is I, and this is F. All right, next we look for H. What comes after H? So if you look here, you're gonna see that H is here, so that means K comes after H. I'm gonna draw K here. And next is what comes after K and M. So if you look at the table, you see that K and M actually both are the predecessor for N. So that means there is an N node here. I'm going to plot it bigger so I can write N. And M and K, I have to redraw them, and both have to go to N. And this is it. We are done with the network diagram. This is an AOA diagram. Next, we are going to just put the activities time, the expected time on the arrows. So for activity A, it's 5. So I'm going to put 5 here. For activity C, it's 8. So I'm going to put 8 here. For D, it's 2. For B is 7. For E is 3. For F is 6. For I is 10. For M is 8. For G is 1. For H is 2. For K is 17. So now we can actually find the critical path here. All the passes and the critical path. All right, so let's start with the passes here. Path is here, and this is the length of each path. Okay, how many paths do we have here? One path is A to C, then C to D, D to I to M, M to N. So that's A, D, D, I, M, and that's it. So I'm going to draw this here. And the length of this path is 5 plus 8 plus 2, so that's 15, plus 10, that's 25, plus 8, that's 33. The next path is E to F, F to M, so that's E, F, M. The length of this path is 3 plus 6 plus 8, that's 17. The next path is A to B, B to I, and I to M. So that's A, B, I, and M. The length of this path is 5 plus 7, that's 12, plus 10, that's 22, plus 8, that's 30. So that's 30. The next path is G, then H, then K, and then N. The length of this path is 20. G, H, K, 20. So the critical path here is the path with the largest length, or the lengthiest path, which is this path. So that's A, C, D, I, M. And this is the critical path. So this means that the length of the project is 33 days. This is a more clear version of the solution to this problem. You can see the AOA diagram here, and the AON diagram. You can draw it after you draw the AOA diagram more easy. And then you can see the list of passes and the lengths here. So the length of the project is equal to the critical path, which is ACDIM, shown by the green highlighting here. And the length of it is 33 days. So the length of the project is 33 days.